Let's evaluate this integral where C is the circle mod z equal to 2. And when putting denominator equal to 0, we are getting the points z equal to plus minus 3 divided by 2. And both these points lies inside the circle, because what is 3 by 2? It is plus minus 1.5. Naturally, these 2 points lies inside the circle. So we need to apply the Cauchy's integral formula for both these points, right? Okay, what is our fz? Take your fz to be equal to the numerator, right? Fz is 1. And this fz function is analytic inside and on this circle mod z equal to 2, except the points plus minus 3 by 2, right? z इक्वल टू प्लस माइनस 3 बाई 2 पॉइंट्स को छोड़कर हर जगह ये फंक्शन आपका सर्कल पर एनालिटिक होगा, राइट? एनालिटिक मीन्स डिफरेंशिएबल होगा एवरीवेयर एक्सेप्ट these 2 points. Let's move on to the solution. So this is the given integral over this circle. We can write this integral further as, let me first multiply and divide with 4. So we write here 1 divided by 4 into the integral of 1 divided by, we can write this as z minus 3 by 2, the factors z plus 3 by 2, right? dz. Function fz we have taken to be 1, right? Because both these points lies, because when taking this denominator equal to 0, we are getting the points z equal to plus minus 3 by 2. So we need to get the values of f at 3 by 2, and also we need to get the value of f at minus 3 by 2, right? We need these two values. So because your function is constant function, it is equal to 1. So whatever value you put for z, answer is always equal to 1, right? It is a constant function. Fz is a constant function. So for both these values, you are getting the value of the function at these points to be equal to 1. Then is, since fz is analytic inside and on the circle, mod z equal to 2 and z equal to plus minus 3 by 2 lies inside the circle. So now we are going to apply the Cauchy's integral formula for both these points. So the given integral can be written as this. Let's make the partial fraction for these first. Just write here z minus 3 by 2 and here z plus 3 by 2, right? When taking this denominator equal to 0, we hide z minus 3 by 2 and we get the value z equal to 3 by 2. Put this value into this fraction, we get 1 divided by twice of 3 by 2, so that is 1 divided by 3. And when putting this denominator equal to 0, just hide z plus 3 by 2. And we are getting z equal to negative 3 by 2. Put this value into this fraction, that is the integrand. So we have here minus 1 divided by 3. So this integral is now equal to 1 divided by 4, integrating this and writing here dz. Separating this, okay, let's take 1 by 3 outside. It is 1 divided by 12. Integration of, okay, what is 1? It is fz. Fz divided by z minus 3 by 2 dz. Are you getting this? Minus the integration fz divided by z plus 3 by 2 dz. 1 by 3 is taken common from the bracket. So this is equal to 1 divided by 12. Okay, what is the Cauchy's integral formula for, just match the format? It is 2 pi iota f at z naught, right? So here your z naught is 3 by 2. So the value for this integral is 2 pi iota f of 3 by 2 minus the value for this integral by Cauchy's integral formula is 2 pi iota f of, what is z naught here? Minus 3 by 2. Please check this format. Here z naught is minus 3 by 2. So this is further equal to writing 2 pi iota outside of this bracket. What is f of 3 by 2? We know that we have written the value of this to be 1. and f of minus 3 by 2 is also 1 because of the constant function. So it is 1 minus 1. So that is equal to 0. So this is how we evaluate such kind of integrals. Okay, thank you.